Good morning. This will be a tutorial for Beers-Lambert law. We have 6 questions to answer. The first one says that the absorbance of 0.002% weight per volume phenol in 0.1 normal sulfuric acid at 270 nanometer is equal to 0.88. Then the absorbance is 0.88. For concentration of phenol, 0.002% weight per volume. Okay, so this is the concentration for the phenol. Percent weight per volume is the same as gram percent or gram per 100 milliliters. Let's complete. When measured in 2 centimeter pass length. So the pass length or the B equals 2 centimeters. Calculate the A1% 1 centimeter and epsilon for phenol. Okay, so the requirement is A1% 1 centimeter and the molar absorptivity. First of all, we must write the rule. Okay, the rule for the Beers-Lambert law, which is A, the absorbance, equals ABC. Okay, absorptivity times the pass length times the concentration. Okay, we have 2 options. Either the A in A1% 1 centimeter, then the concentration will be in gram percent, or the absorptivity in its molar absorptivity, so the concentration is in mole per liter or molar. Okay, so here the first requirement, we need the A1% 1 centimeter. So the concentration must be in gram percent, and this is already the given. The given is 0.002% weight per volume, which is the same as gram percent, as we said. So here we want the absorptivity. So we will say that the A1% 1 centimeter equals the absorbance divided by B times C. Okay, which is equal to the absorbance given in 0.88 and divided by the pass length given in 2 centimeters times the concentration, which is must be in gram percent, it's 0.002. So the A1% equals 220. Even if it's an in-between step, okay, we must write the rule and the unit. So the unit for the A1% 1 centimeter is deciliter, gram -1, centimeter -1. Okay. So here we finished the first requirement. The second requirement is the epsilon or the molar absorptivity. In order to get the molar absorptivity, the concentration must be in mole per liter or molar concentration. It's much easier to convert the A% 1 centimeter to molar absorptivity than to convert the concentration in gram percent to mole per liter. Okay, so we have a rule to convert the A1% to molar absorptivity or epsilon, which states that the epsilon equals A1% 1 centimeter times the molecular weight divided by 10. Here, the A1% 1 centimeter, we got it from the previous step, which is 220, times the molecular weight. It's given that it's 94.11. This is the molecular weight for the phenol, divided by 10. Okay, it's equal to 270.42, and we must write the unit, which is liter mole negative 1 centimeter negative 1. Okay, and this is the first question. Let's move to the second question. Okay. Calculate the concentration in microgram per milli of a solution of tryptophan. Okay, so what is the requirement? The requirement is to get the concentration in microgram per milli. Okay, and given that the molecular weight for tryptophan is 204.2 in 0.1 molar HCl, giving that the absorbance equals 0.613 in a cuvette, okay, of pass length 4 centimeter. Okay, so the cell or the cuvette is 4 centimeter at its lambda max 277 nanometer. The epsilon or the molar absorptivity is 5,432 liter mole negative 1 centimeter negative 1. Okay, so the given is that the molecular weight is 204.2. The absorbance is 0.613. The pass length of the cell is 4 centimeters. And the molar absorptivity is 5,432. So, first of all, we will write the rule, which is the absorbance equals ABC. Here we have that the absorptivity is molar absorptivity. We said that it's much easier to convert the molar absorptivity to A1%, okay, or the A1% 1 centimeter to molar absorptivity than converting the concentration from mole per liter to gram percent or microgram per milli. So first, we will think about that we want to calculate the concentration in microgram per milli. So it's easier to have the concentration in gram percent and convert from gram percent to microgram per milli than having the concentration in mole per liter and then converting it to microgram per milli. So we will convert the molar absorptivity to A1% 1 centimeter using the rule A1% 1 centimeter equals epsilon times 10 divided by the molecular weight. The epsilon given that it's 5,432 times 10 divided by the molecular weight, which is 204.2. We will have A1% equals 266.014. Okay, and we must write the rule, which is deciliter, gram negative 1, centimeter negative 1. After that, we will substitute in the Beers-Lambert law. The absorbance equals 0.613 equals the absorbativity in A1%, 1 centimeter. Okay, we got it from the previous step, 266.014 times the pass length, which is the B, is 4 centimeters. Okay, times the concentration, which is unknown. Okay, and here we will have the concentration in gram percent. Since that, we got the A1%, 1 centimeter. Okay, so the concentration will be equal to 5.76 times 10 to the power negative 4. And what is the unit for the concentration? The unit for the concentration is gram percent, or percent weight per volume, or gram per 100 milliliters. Okay. What is the requirement? The requirement is the concentration in microgram per milli. So I'll convert the gram to microgram. From gram to milligram, okay, we will multiply by 1,000. And from milligram to microgram, we'll multiply by 1,000. So from gram to microgram, we will multiply by 10 to the power 6. Okay, so 5.76 times 10 to the power negative 4 times 10 to the power 6. Will be equals to 576 microgram percent. Microgram, okay, percent, or per 100 milli. We wanted per 1 milli, so we have 576 microgram in 100 milli. We wanted in in 1 milli. Okay, so we'll do crisscross, okay, 576 times 1 divided by 100 in order to get the concentration in 1 milli. Okay, so here we'll say 576 times 1 divided by 100. Okay, we'll find it that it's equal to 5.76 microgram okay per milli. And this is for the second question. Let's move to the third question.